Quadratic equations. There are many situations where data obtained does not show a linear trend. It changes its behavior in the middle. For example, temperature measurements taken in 24 hours time interval first increase and then decrease. To make a mathematical model, we use quadratic functions, and equations associated with such quadratic functions are called quadratic equations. A quadratic equation in X is an equation that can be written in the form ax squared plus bx plus c equal to 0, where a, b, and c are real numbers and a is certainly not equal to 0, because if a is equal to 0, then it doesn't remain quadratic anymore. So let's take a standard form of the equation. So general form of quadratic equation. General form of quadratic equation. Quadratic equation. We will use different methods to find such values of x which will satisfy this relation ax squared plus bx plus c equal to 0. This is a typical form of the quadratic equation. Now, in order to find solution, we mean finding the values of x which can satisfy this relation. The first method that we are going to study is square root property. So first method would be square root property. This method is only used when b is equal to 0. So when b is equal to 0, this is a very good method to use for finding solution of the quadratic equations. But we'll study different methods, and each one of these methods can interchangeably be used to find the solution. Let's first find solution for the given example. Here x squared is equal to 4. So given equation is x squared is equal to 64. If we want to take a look on this to compare it with standard form, we can certainly write x squared minus 64 equal to 0, and then we can write x squared plus 0x minus 64 equal to 0. Here a is equal to 1, b is equal to 0, and c is equal to minus 64. See, it still follows the general form of the quadratic equations. Here the condition was only that a cannot be equal to 0. Anyway, so in order to find solution for this kind of equation where b is equal to 0, I mean there is no coefficient of the variable involved, whether it's x or t or y, whatever the variable being used is. Now we know that if x squared is equal to 64, then there are two possible values for x. Then x is equal to plus minus 64 square root. This is equal to plus minus 8. So both of these values will satisfy the given equation. The verification could be that if we replace 8 squared is equal to 64, obviously 8 times 8 is 64, so 64 is equal to 64. And if we replace x equal to minus 8, that would be minus 8 squared is equal to 64, and this would be 64 equal to 64 as well. Let's take another example. Example number 2. And in this example we have t minus given equation is t minus 5 whole square is equal to 18. If this is the case, then we can see that t minus 5 is equal to plus minus 18 square root, and we can transfer minus 5 from left hand side to right hand side. So this will be t will be equal to plus 5 plus minus 18 square root, and we know by changing 18 into its linear factors, 18 can be written as 9 and 3 times 3, 3 times 1. So this t could be written equal to 5 plus minus 2 times 3 times 3, and taking the square root, we can take 3 out of this pair. That will give us t is equal to 5 plus minus 3 times under root 2. So here under root 2 is irrational number and 3 times under root 2 is irrational number, but that's value of t. And if we want to verify, we can also verify this solution as well. Let's do another question, but anyway, this solution is an irrational number that is going to satisfy this equation. Example number 3. Example number 3. Now given equation is 9x square plus that is given equation. Given equation is 3x square is equal to 75. If that is so, then x square will be equal to 75 over 3. This means x square is equal to 25, and x will be equal to x is equal to plus minus 5 square, that is equal to 5 times 5. So this x is going to be equal to plus minus 5. So these are the values of possible values of the x, and for verification purpose, verification can be done by 3 times 5 square equal to 75, and another time is 3 times minus 5 whole square is equal to 75, and in both cases 75 is equal to 75. So this is 75 equal to 75 as well. This is called the square root property method for solving quadratic equations. And now there is one more situation where we model a situation that follows a quadratic equation. For example, if the given literal equation, example here, the given equation is d equal to 4.9 t square, and if that is the case, then we will find value for t. This means t square is equal to d over 4.9, and t is equal to plus minus d over 4.9. square root, and this could be written as t is equal to plus minus 10d over 49, and when we take the square root, t will be equal to plus minus 10d square root divided by 7. And now for whatever value of d, we can find the value of time. For example, if this equation was to model distance against time, maybe this was a free fall. If an object is falling freely from vertically, then it might be required to find the time against a given distance for object to fall. Then at d is equal to 10 meter, what would be the time? How much time it will take, we can calculate, and that time can be taken as plus minus. Here that would be 10 times 10 over 7 is already, so this is equal to plus minus 10 over 7. So this is time, and because time is never negative, since t less than 0 is absurd, so the time taken by the object to fall through a distance of 10 meter is t is equal to 10 over 7 seconds. So this is how we use this property, and it's usually used against vertically falling object and many other situations as well. So this is one method for solution of quadratic equations, and in the next lesson we will solve quadratic equations by using another technique called factorization.